Today we're going to graph logs. And we're going to start with the common log, log of x. Now remember, the common log means the base is 10. It's never going to be written, but that's what we're going to assume, your base is 10. So let's plug in different values of x and make a table. So remember, your base is 10 for the common log. So let's plug in a 1 right here. Well, I know, I'm plugging in a 1. I know that 10 to the power of 0 will give me 1. So your y value is 0. Let's plug in a 10 this time. My x value is 10. 10 to the power of 1 gives me 10. So I know that this answer is 1. So this is the table for my common log. And remember, the base is 10. So I'm going to go ahead and plot those points. 1, 0 is right here. 10, 1 is right here. And my asymptote is right along here. This is my asymptote. That is the line that I cannot touch. So I'll go ahead and draw my graph. This is the parent function of the log. And try to draw it pretty. So let me draw it again. And go through those points. There we go. So this is the common logarithm. Let's talk about some of the attributes. So your domain, it goes from the left at 0, it starts at the asymptote, and then it moves that way towards infinity. So that's 0 to infinity. This needs to be a parenthesis because there's an asymptote here. You cannot be on the asymptote, so no brackets, only a parenthesis. Your range, it goes down forever, so that's negative infinity, and then it goes up forever, positive infinity. Okay, let's talk about the end behavior. So, as my x values go to the right towards infinity, as we go this direction, my graph is going up. So that is infinity. If we went the other way, well, my graph never goes this way towards negative infinity. So this does not exist. You don't even have to do that. We just have one limit. It never goes this way. There's nothing over here. So that one does not exist. Okay, one more thing, the asymptote. Your asymptote, this is a vertical line. So vertical lines have an x equals, and this is at the x-axis at 0. So this line crosses the x-axis at 0. So that is the equation of your asymptote. Also, if you wanted to talk about increasing and decreasing intervals, this is always increasing. Whenever you give the increasing interval, you're giving me the domain where it's increasing. So it's increasing from here forever, so that's 0 to infinity. You're thinking about the domain of where it is increasing. So those are some attributes for the common log function, okay? So now you know how to graph it. Now, your table will always be 1, 0, 1 for your parent function, and this number will always be your base. So in this case, the base was 10, that's why I put a 10 right here. So that's a quick trick. Let's try another one. Here, your base is 10. This is the common logarithm. So I'm gonna put 10 right here as my base. So I'm gonna graph the parent function, 1, 0, and 10, 1. That's what that looks like. That's just the common log. But we're transforming it. We're transforming it by shifting it to the left 3 and down 4. So since it's going left 3, that affects your asymptote. Your asymptote is no longer here at 0, it moved to the left 3. So now your asymptote is right here. So your asymptote is at x equals negative 3. That's where your asymptote is. Okay, it's at x equals negative 3. Now, your points went left 3, down 4. So this point went left 3 spaces, down 4. It is right here now. This point went left 3 spaces, down 4. It is right here. So this is what your new graph looks like. So the domain of the transformation is from negative 3 to infinity. Your range is still all real numbers, or you can put negative infinity to infinity. Your end behavior, as x goes to the right, your graph is still going up. And it is always increasing. It's increasing from -3 onward. So your increasing interval, it is increasing from -3 to infinity. You're always thinking about the domain where it is increasing. And your asymptote, we said, is at -3. X equals -3. Okay, so that is one way how you can graph these. You can just plot the parent function and then move your points the way they told you to. Now, one thing that I want to point out, whenever you are in the parentheses, that affects your x values. That affects this part of the table. Okay, so since we went left 3, these x values moved to the left 3. So think about subtracting 3. So your new points for x are -2 and 7. Okay? Over here, what is outside of the parentheses will affect the y values. So here we subtracted 4. So 0 minus 4, that's -4. 1 minus 4, that's -3. So if you look here, that's where my new points are. -2, -4, -2, -4, that's right here. 7, -3. 7, -3, that's right here. So guys, you can either just graph your parent function and then shift your points. Left 3, down 4, draw your graph. Or use the parent table, 1, 0, 10, 1. You know that things inside of the parentheses will affect the x values. So this is left 3, subtract 3 from the x column. This is down 4, that affects your y values. Subtract 4 from your y column. These are your new points. You can plot them on your graph. Let's do another example. Okay, you always have these numbers, 1, 0, and then your base goes here. Your base in this problem is 2. So I'll put a 2 right here. And I'm going to plot the parent function. The parent function is just a log with base 2. This is the simple parent function. So I have 1, 0, and then 2, 1. And that is my parent function. And this is your asymptote. Okay, now the transformation here is it went to the right 3 and it went up 5. It's always the opposite inside of the parentheses, okay? Whatever is inside of here with x affects the x column, okay? Whatever is outside of the parentheses, such as the 5, will affect your y column, okay? So these points, I can move it to the right 3 and up 5. So move this point right 3, up 5, that's right here. Move this point right 3, up 5, that's right here. So this is your new graph. Also, your asymptote moved over to the right. So this is your asymptote, and this is your new graph. Okay? So you can do it graphically. That's my new graph. Or you can use your table. So this went right 3. So you can add 3 to your x value since it went to the right 3. Your y values, they went up 5, so you can add 5. So here's your new table. 1 plus 3, that's 4. 0 plus 5 is 5. 2 plus 3, 5. 1 plus 5, 6. These are the new points in your table. Just put them on the graph. 4, 5 is right here. 5, 6 is right here. So guys, you can either use your table or you can just move your points. Let's do another example. Okay, so my parent function, this is my base. So for my table, that is my parent function. I'm going to graph it over here. The parent function is just a log with base 3. No transformations, just the parent function. 1, 0 is here. 3, 1 is here. So this is my graph. And your asymptote, of course, is right there. Okay, so let's write down the transformations. Nothing is in here with x, so nothing affected the x values. my transformations are outside of my parentheses. So these affect the y column, okay? This is a reflection over the x-axis. This went down 4, okay? So negative will affect your y's. These are now negatives. And it went down 4. So I'm going to subtract 4. So my new table, the x didn't change because there's nothing happening in my parentheses here. However, this is -0, which is just 0. -4 is -4. -1 minus 4, that's -5. So you can plot these points in your graph. Let me show you how to just transform the points. So it's a reflection over the x-axis. So this is your x-axis. That just stays the same because it's already on the x-axis. And then it goes down 4. 1, 2, 3, 4, right here. This point, first it needs to reflect across the x-axis, so it's right here. And then it goes down 4. So this is where your graph is. That's where your point is. So this point, it flips across the x-axis. Now it's here. And then it goes down 4 spaces right here. So this is my new line. Get close to the asymptote and then go through those points. That is what your graph looks like. And notice these points match what's on your table. 1, -4, 1, -4 is right here. 3, -5, 3, -5, that's right here. Okay, let me show you what just happened. Normally, your graph looks like this. However, it reflected across the x-axis. So now it looks like this. You see that? They're mirror images of each other. You can fold it on top of each other and it'll be on top of each other. They're reflected. Okay, and then it went down 4, so this just scooted down. So now it's down here. So those are the steps of what happened. So you can either do it on your table, transform your table, and then plot the points, or you can just transform the points from your parent function. Let's do another example. Wait, before we do another example, let me go ahead and give you some attributes. So we have our transformations listed. Let's talk about the domain. Your domain is still going from the left to right, so 0, and it goes that way. So your domain is still 0 to infinity. Your range, it's pointing down and then it's going up. So that's -infinity to infinity. Let's look at your end behavior. As we move to the right, as we move this way, your graph is going down. So that's -infinity. So that's different. Your asymptote, it did not move left to right. So your asymptote, it just stayed where it was. This is your asymptote right here. The asymptote is at x = 0. And this time it is decreasing. Notice as we follow the line, my finger is going down. It is always decreasing. So the domain where it is decreasing is from 0 to infinity. So those are your attributes. Let's try another example. Now we have this one. Now remember guys, this is just called a natural log. A natural log is a log with base e. However, for some reason, they like to write it as this, an ln. So you just imagine that your base is e, okay? This is the same thing as this, okay? These are the same thing. So our base here is e. So I'm gonna put e as my base. And guys, remember, e is approximately 2.718. It's approximately 2.718. So I'm gonna go ahead and graph the natural log function. This is the parent function. 1, 0 is right here. And 2.718, 1 is about right here. And your asymptote is still along x = 0. So that is my graph. Okay, so now we have some transformations. Notice, guys, this is inside of the parentheses with x. That means it is going to affect my x column. So all of my x's are now negative. This is not inside of the parentheses. That will affect the y column. So this goes up 1. So I'm going to add 1 to all my y values. So my new table is -1 with 0 plus 1 is 1. Negative 2.718 with 2. 1 plus 1, 2. So this is my new table. You can graph these points, and that's how you can graph the transformation. Or you can just transform your points that are already here. So this is a reflection across the y-axis because it's inside. So that affects, this point will crop over the y-axis. This is the y-axis. And then it'll go up 1. So this point will hop over the y-axis, so it's here, and then it'll go up 1, so now it's here. So that's how that point transformed. And look, -1, 1 is its location. -1, 1. That matched. Next, I'm going to reflect this point over the y-axis, so it goes right there, and then it moves up 1 right here. And notice that matches what I have in my table. -2.718 goes with 2. So this is my transformed graph. You get close to the asymptote and go through those points. Maybe I can draw it better. Close to the asymptote and go through those points. So that's what your transformation looks like. Let's talk about the different attributes. So your domain, on the left, it's going this way forever. That's -infinity, and then it gets close to the asymptote, which is at 0. Your range is still all real numbers. It'll always be all real numbers for logs and natural logs. So it goes down forever, up forever. Your end behavior, your graph is going this direction. So as x goes to the negative side, let's see what happens to your function, what your y values do. So as I move this way along the x-axis, your graph is going up. So that's infinity. Your graph goes up as you move to the left. So that's why it's infinity. If you wanted to ask about this side, as your graph goes positive this way, well, there's nothing over here. It's over here. Our graph is on this side. There's nothing over here anymore. So this does not exist. You don't have to do that one. Okay, now as I follow my graph, my hand is constantly going down. If I start over here, it's constantly going down. So this is only decreasing, and the interval where it's decreasing, the domain is -infinity to the asymptote. So that is where it is decreasing, the interval where it's decreasing. And we already said that the equation of our asymptote is at x = 0.